Welcome and thank you for joining us for another episode of the Revolutionizing Irrigation training series. I'm your host, Richard Restuccia, and today we're going to be talking about soil moisture sensors and how to use a soil moisture sensor to properly schedule your irrigation. This was a conversation I was having with Connor many times over the past few months. And, a lot of us are more familiar with getting ET data to set a schedule, or using what we used to do, we just repeat. And these can be good, but certainly soil moisture sensing, this peak under the soil profile line as to how much moisture is actually in your soil, is a really valuable, very valuable information to have. And so taking us through this exercise of learning how to use soil moisture sensors to schedule irrigation is Connor Cunningham. He's the territory account manager for Mana. Mana is really the merger of Jane Logic and Jane Irrigation technology with Mana. Connor has been in this industry since college, Fresno State grad. And, when you start to think about people that have been in this industry, technology of irrigation, 10 years plus, there's not that many, but Connor has seen a lot of technology. He knows it very well, and he does a great job on these webinars explaining to us how to use the technology, which is really important to us. So anyway, Connor, welcome. Thank you for joining us for another webinar.
Thank you very much as well. And I always sit a little bit straighter after you give my introduction, makes me feel good.
Yeah. You have to pay attention a little bit more,
right? Yeah, no, I really do feel blessed for getting involved with the agricultural industry at the time that I did, because I always used to say this, and I still do. Soil moisture sensing technology has been around for decades now at this point, multiple decades. And when I started, really the ability to remotely gain access to that data was where it was really starting to emerge and grow. And then where it's really started to shift over these past few years has really shifted from, hey, not just get access to the data, but actually have the data work for you and be able to understand it in a way that you can use it practically, which is definitely right on the head for what we're going to be talking about today. So I do feel very fortunate. I know a lot of people still consider me very wet behind the ears, and that's okay. I'm happy to learn and happy to grow still.
Yeah, well, I mean, you are young, but you have a ton of experience. I know you're managing water on farms with some of your water management services customers, and I know they're all thrilled with the work you're doing. They're having really positive experiences there. So it really says a lot. I don't think we can find that many people in California doing what you're doing. So it's real special to have you on. And then I just want to say this about the probes too. We're looking at these probes, and I love this because I often think of, you're in Fresno. I think somebody driving in a truck from Fresno to Bakersfield and not having a fuel gauge, right? I don't know how much fuel is in my tank. Mm-hmm. So what I think they would do is they'd immediately go fill up, right? They'd put some gas in that tank, and then they'd start driving, and then they wouldn't really know how far they could go, right? So you just keep on filling up and filling up, because if you run out, you've got a disaster. And people do with water when they don't have a probe or a soil moisture indicator of some sort that shows them how much moisture is in the soil. I think they just overwater as a result.
Right. And I actually love that example of driving from Fresno to Bakersfield, because that's my normal beat. That 100 or actually be 260 mile round trip is something that I'm very familiar with. And it very much would be that case where if you say, well, hey, you know what? I know I always have to put in 26 gallons. Well, if you pull up and you got half a tank left, but your tank can hold 26 gallons and you put in 26 gallons, well, there's going to be gas sloshing all over the place. And you say, well, at least my tank is full. And then you keep driving, right? So kind of in that same thread of that same metaphor is, I can't get hurt if I'm sloshing over because I know that I have a full tank, versus being stranded on the side of the road. It's 112 out and it's August 31st. So to kind of go along with your metaphor there, that's where I think a lot of people's thought processes are. And that's very smart. You have an investment in the crops that you have in the field, and better to overwater and have too much than to shortchange yourself, hurt the crop this year, hurt the crop the following year, so on and so forth, and all the issues that come along with that. So I think that's great.
Yeah.
But yeah,
So
so
Connor, looking at the
Go for it.
screen right now. Yeah, so I was going to say on the left, right, I see a couple tensiometers and then a Syntec probe. Is that right?
Yeah, that is correct. So I wanted to start off today's discussion by actually looking back. This is actually a slide from one of my previous presentations that I gave where we talk about selecting the right type of tool for your operation and for your budget. So I wanted to quickly call on that really quick to put a mental image in our minds before we started actually looking at the data and diving into how we're going to use this to create our irrigation schedule and manage our irrigation. So on the left-hand side of the screen here, for those of you listening at home, you can actually see that we have a couple of traditional tensiometers, and these devices, they have one sensing point per depth. If you wanted to monitor 3 feet, for example, traditionally people would take one device at a foot, one device at 2 feet, one device at 3 feet. So you'd have 3 different sensing points and 3 different devices that you'd have to manage and maintain. Compared to the image on the right-hand side, this is actually a probe provided by a company called Syntec, and they have created this soil moisture probe that is called a capacitance probe. And the difference here being you have a single probe, and every 4 inches down the length of the body of that probe, there's a soil moisture sensor. So you can see that represented by these gold radiuses coming off of the probe here, showing you, hey, here's where a sensor's at, here's where a sensor's at, so on and so forth, down the length of the body. I like this, and this is what we're going to be talking about today, is data coming off of a capacitance probe like this. It gives you a lot more granular insight into not only peeking below the surface, seeing what's going on, but it gives you a better view of how does the moisture move through your soil and how does the soil interact, so that way you can make the proper management decisions and schedule your irrigation accordingly. So, that's why I just wanted to start here, give everybody this visual representation, and then we can hop over and start looking and diving through some of the data.
That's pretty cool, Connor, because I think about it. If I had to do it with an individual probe every 4 inches, I think if I was going to 3 feet, I'd need 9 probes.
Right.
But I get all that here in one shot. So that's really awesome.
Yeah, exactly. And so, I mean, realistically, at the end of the day, whatever probe you decide to use, the concepts that we're going to be talking about today are going to be the same. But we're definitely going to be looking at this through the lens of Jane Logic, because this is the product that I provide, and this is the product that I use on a day-to-day basis when I'm working with the growers that I work with. So just to keep that in mind here.
Yeah, so these Syntec probes, they connect directly to Jane Logic software.
That is correct. Yeah, these Syntec probes connect to our devices, and then those devices will then send that data directly to Jane Logic every 15 minutes.
Yeah. And just for those that aren't familiar with this, so that probe connects to some sort of telemetry unit that passes the data back and forth.
That is correct. Yeah. So what we have is we have our in-house telemetry unit, which is called a C3. And, don't tell anybody, but we have some more products coming out that we'll be doing some future releases on that will also be able to connect to soil moisture probes. So don't want to talk about it too much, but definitely want to try to get folks excited about what's coming for the future, that we're continuing to expand and grow our portfolio of offerings to growers so they have that many more tools available to them.
I'm glad you mentioned that, Connor, as far as the probe and how it connects, because look, this technology in a lot of ways is really complex, and you can get a lot of data. And I always say, go take your cell phone and put it on a stick and put it in a farm field and leave it there for a year, and let's see if it still works.
Right.
Right. So this technology has to be bulletproof and it has to work, and it does. The other thing about it, though, is it's fairly simple. A soil probe, telemetry unit to your dashboard on your computer.
Right.
That's a pretty smooth transition, and what a great way to get your information.
Right. And I'm glad you bring that up, because realistically, what we're doing and what we're talking about is what people have been doing since the inception of, or excuse me, the conception of agriculture on Earth. So this is what people have been doing for eons. How much moisture do I have in my soil? Can I make it until I put more water on? Yes or no?
Yeah.
At the end of the day, that's really realistically what we're doing. The only difference is in today's modern age, we have some tools that are available to us to help make those decisions a little bit more efficient, especially when costs of production are going up and price of goods is going down for the farmer. So it's a really helpful tool to have when we're living in a day and age where we're faced with these types of challenges.
That's a great point, Connor. People really have to be watching their costs right now, and cost of labor has got to be right at the top.
Right, definitely. Labor is number one cost across the board for everybody who's working in production agriculture. And so if you can try to cut back on that labor in any way, shape, or form, you're going to help yourself weather the storm until hopefully things can change. And talking about weathering storms, the whole reason that I think having access to a soil moisture probe and having that real time, or what I would say near real time information is really helpful with, is being able to understand, hey, water and soil are typically things that I can't change in this equation when I'm thinking about balancing my budget and trying to put on enough water and also produce a crop. Water availability is not usually something I can change. And well, you might be thinking to yourself, yeah, but we had an awesome winter and we had all this free water coming from the sky and supposed to be another great one. Exactly my point. We can't control when we have these awesome winters, and we can't control when we have a drought, right? So being able to peek under the surface, understand how our soil is interacting with our water, so that way we can capitalize on some of those factors that we can control. So that way we can make sure that we can make the most efficient management decisions possible.
Yeah. Okay, great. So Connor, I wanted to remind everybody that we do have the Q&A in the chat open. And Connor, we've already got a couple of questions for you. So this is one thing's for sure, is your crowd is always engaged, and we really appreciate the questions. So one person's asking that they have several probes like you showed on your slide, but they discontinued service. Can I reuse my probes now?
Yes, if they're those Syntech drill and drop probes, 100%, we can reuse those. That's not a problem. And that's, unfortunately, the reality for some folks is they do lose service from other providers, but they've made this investment. And so thankfully we work with these third-party sensor companies, so that way we can reuse people's investments and they can get more value out of that over the long term.
Yeah. Okay, great. Thank you. It's good to know, right? We're not wasteful. You can keep reusing them as you start your service again. So that's great.
Exactly. Yep.
We have another person asking, and you don't have to answer this now. I think you're going to answer it in your presentation, but can you display irrigation events using this software? And I think you'll do that. You'll show that, right?
Yep, definitely. So thank you for paying attention and getting ahead of the curve here. Yes, our system does show that. And I think that's an important factor when you're considering soil moisture and how that plays a role in scheduling your irrigation. So we'll look at some examples right here, right now. So we have an actual live customer account here. I've changed all the names to keep anonymity. I believe I said that word correctly. A little tongue-tied today, so I apologize. But anyways, neither here nor there. I wanted to show a live example and what it actually looks like to run through some of this data for our irrigation scheduling. So what I like to do is when I start off, I start to think about how much do I have and what's going on in my root zone, right? So typically what we like to do as a starting point is actually start off by determining what our root zone is and ground truthing that probe. Now, again, I did a whole other webinar on ground truthing the probes, and Richard, you and your team have done a great job of cataloging those webinars. So you can go back, listen to that, learn about the process of going through and ground truthing the probes. So let's assume that in this example here that we've ground truthed the probe and that the readings are as representative as they can be of the actual field conditions, right? So the very first thing that I want to do is I want to go ahead and look at my soil moisture probe here that I'm interested in. So I go ahead and click on this one, and it refreshes the data on the right-hand side here for me. And I'm going to go ahead and see kind of what my current status is of my root zone that I've set up for myself. Now, if you don't know what your effective rooting zone is, sorry, I mixed up some terms here. I call it root zone, but what I'm talking about is effective rooting zone, or what our target is, right?
Yeah.
So a lot of people will use the term effective rooting zone. So in this example here, we're looking at an almond block, and typically almonds have an effective rooting zone of the top 3 feet. Now, we do know that their roots go deeper because wherever moisture is present, roots will grow. But in the top 3 feet, that's where we not only have our roots that are drinking, but we have our fibrous, hairy roots that are also eating. They're consuming the nitrogen and the fertilizer that we're applying to the field. So that's why we call it effective rooting zone. So once I have a gauge of kind of what my current status is, I keep that in the back of my mind, and then I start to think about, okay, how has the water been moving through the soil at this point in time? So I'm going to go ahead and continue to scroll through Jane Logic here. And I'm going to come down. Go ahead, Richard.
Yeah, I'm sorry. Can you go back to the original?
Of course. Yes, my pleasure.
So what's the pink line across the bottom?
Great question. That is a great question. So talked about ground truthing probes. So when we ground truth probes, the reason that we do that is so that way we can start to set where we determine is too wet and where we would determine is too dry for this soil type, for this crop, for this probe type. So this pink line right here at the bottom is what we've determined as being too dry for what we would like to see when we're managing our moisture in our root zone right here. So this line right here is as a result of us doing the ground truthing and understanding, hey, we really realistically don't want to get drier than this point. And so as the moisture starts to move, accumulate in the soil, and we see these lines go up, as it starts to drop, that means that our moisture is starting to dry down. Now, this is thinking about the time of year. This is most likely a result of getting ready for harvest activities, making sure that the ground is dry and hard, so that way the sweepers and the blowers and all the other machinery that's moving through the field can get in there. But normally, this pink line is an indicator of, hey, we really don't want to get below this line when we're normally irrigating, so that way we're not hurting our crop.
And Connor, for those that think of a question after, you'll be providing your contact information at the end, right? To so they can get a hold of you.
Yes, definitely. I'll pull that up and put that on the screen for everybody. So thank you for putting that up. Yep.
Okay. All right. Great. And yeah, I'll also add, and if anybody correctly identifies Rusty Shackelford in an email to Connor, they'll send you a hat, or we'll send you a hat. But you got to reach out to Connor.
Yes, that's a fun little Easter egg. We'll see if anybody catches on to that or not. We'll have to start doing that. I'll have to come up with interesting Easter egg names, then I'll be part of our contest.
So, okay.
So coming back. So
yeah,
now we've understood, hey, go ahead.
Yeah, you just froze for a second. So that you're good now.
Okay. All right. No worries. All right, so now that we have an understanding of what our current soil moisture status might be in our root zone, now I like to then look at how has the water been interacting with the soil profile as a whole. So I talked about setting goalposts for ourselves, understanding our effective root zone. Jane Logic actually visualizes that to make it a little bit easier on ourselves. So you can notice here in this box that we have this green shaded area in the middle. And what that is we custom set that up for each one of our soil moisture probe instances. And we say, this right here, these are your goalposts. So for our football fans out there, if you're trying to kick your field goal, you want to make sure you keep it in between these goalposts, right? So to make sure that you're getting those points and that you're doing the right job. And as the moisture penetrates through the soil, that's what these bars that come down are. That's the actual moisture from the probe readings that we just saw up top. That's the moisture coming down. So realistically, you just want to think of this as a cross-cut section of your soil. And then to answer the other viewer's question here, these blue bars, these highlighted bars here, you can see when I run my mouse across it, those are the irrigation events being captured by the pressure sensor that's tapped in line with the irrigation system out there. So now, kind of starting to think about irrigation management and planning for irrigation and irrigation scheduling, now we can start to see how efficient has our irrigation been, because irrigation efficiency is how much, how often. So we can see here that after we hadn't applied irrigation for, oh, let's see, over a week here, when we put on 16 hours, we got down to a depth of 28 inches. And this is a really important concept to take into consideration. If your soil is wet or if your soil is dry, your water will penetrate at different rates into different depths. So if your water, for example, if your soil is too dry, the surface of your soil will actually lock up and crust, and you won't be able to get any penetration until you've stacked what they call stacking the water on top of it enough time to try to break some of that crust up and start to get deeper penetration, because just the physics of water molecules stick to themselves. So on the opposite hand here, this is actually a good example. We can see that by putting too many irrigation events in a row, we'll actually start to flush water out the bottom. Sometimes during the season, we want to do that, but during the main part of the irrigation season, we really want to try to keep it within those goalposts that we set for ourselves. So this is a really helpful view for us to look at our soil moisture readings and understand how often and how much water do I need to apply. So now we're continuing to formulate our irrigation plan based on first how much water we had. Now we're looking at how much in number of hours and how often we need to be doing that irrigation.
Yeah, it's pretty enlightening, right? This is the secret sauce right here. How far did my water penetrate, and when can I turn it off, right? And so we've got a couple other questions coming in, Connor. One person is asking, well, gee, how many probes do I need in my farm?
It was one of my favorite questions. I get asked it almost weekly, and it's one of my least favorite answers of it depends.
Yeah. That's the answer to almost every irrigation question I've ever
unfortunately had. However, I've actually started to kind of break it down into camps. You know, how many management zones do you have? So how many irrigation sets do you have? How many different soil types do you have? And how many varietals do you have? You can really kind of break it down into those three right there. Well, I guess the fourth one would be how much money do you have too?
Right.
So I'm not saying that you have to account for all four of these, but these are 4 points to consider. How many probes do I need? Well, we all know of fields here across the valley that we live in alluvial floodplain. So what that means is after decades and centuries of water coming down off of the Sierras, that soil has been layered and moved around here on the valley floor. So all that to being said, we can all probably pinpoint multiple fields right now in our head that have at least 5 different soil types. Okay, so soil type is definitely not going to be, you know, the one that you're going to be basing your number of probes to put out there. It would be more based off of how do you manage that whole ranch. If you're managing it in 2 sets, put 1 per set. If possible, you know, that's where the financial component comes in, right? If you can afford to put 1 in each set, boom, I think you're good at that point in time. So, you know, that's part of a bigger discussion, but just to briefly answer that question.
Yeah, so it's kind of, you've got to put some experiential variety in here too, right? It does count, right?
Right. Definitely.
So another quick question here, Connor, on the depth in inches. We see this on infiltration. That first diagram that you were showing us, that first shot.
Oh, the first box?
Yeah, the first plot.
This one here?
It's actually showing us some other units, 40 to 63. What is that? Is that how much moisture percentage is in the soil? What is it?
So we call that moisture units. And what that is, that's a unifying number. Because we work with third-party devices, what we decided to do was, instead of trying to visualize everybody's units in a different way, which we can do, we actually have found that it's more beneficial to create this unifying measurement called the MU, or the moisture unit. It's very clever. And the reason that we do that is because we do other processes like the ground truthing process, because everybody's soil is a little bit different. Everybody's microclimate's a little bit different. Everybody's crop is a little bit different. It's best to utilize this to create an instance for yourself, ground truth it, get your own data set that's specific to you, specific to your farm, specific to how you operate, instead of trying to say, well, the research says that you need to do this, this, and this. Yes, take that with a grain of salt. You need to remember that information from the research, but you also need to layer that with how you operate individually and specifically.
Yeah, that's pretty cool that you guys took the time to do that. Makes everything very uniform for the users.
Yeah, well, again, I'm still a little wet behind the ears compared to some of our more senior members on our team. This is not our first rodeo, as you can tell. We originally started off as a company called PureSense. And then as that was acquired by Jane, another company, Observant, was acquired by Jane, and they married those two together. So we've been doing this for well over a decade, probably almost two at this point. So we've got a lot of experience on our team working with this type of technology and information.
That's for sure. You've got a really experienced team. When I think about it, there's, you mentioned a couple decades, and there's quite a few team members that have been around for all that time.
Yep, 100%, 100%.
Yeah, lot of value there. So somebody was asking about the cost of probes. Are they expensive?
Yes, they can be a little costly, but if you think about it, you're going to be buying something that doesn't wear out. So very common, people are very familiar with like a watermark sensor, right? Watermarks, super cheap. You can get them at any irrigation store, any irrigation supplier, and you can put them out there. But in my mind, I consider those disposable. They're actually composed of and made from gypsum. And so what happens to gypsum in the soil when you put water on it? Starts to dissolve. So yes, there are some cheaper options out there in the marketplace, but you're going to be replacing them every so often, and your data, bad data in, bad data out. If you're not paying attention to how long ago you put that device in, well, you put yourself at risk of not having accurate representation of what's going on in the soil. So yes, these devices that I work with are considered to be more expensive, but in my mind, you're making an investment that's going to last you 15, 25 years. And you're going to be getting reliable information from that at a much more granular level too, because those cheap sensors, you're putting one for every instance that you want to check, instead of just buying the one and you're done.
Yeah. So Connor, if I have a one Jane Logic subscription, is there a maximum number of soil probes on a ranch or a farm that I can connect to it?
Nope. As many as you want to put out there, we can handle it. We've got instances where we have what we would call high density, where we have, like 200 acres, and we've got over 14 probes out there. And we also have over, 23, 24 control instances. And that's not even counting the filter station on top of that. So yeah, the system doesn't care. It's going to display the information that you want. So it's really just, again, it comes back to that economic leg of the equation there.
Right. Okay, great. And then somebody else is asking about the locations of the probe. Now, I know you covered that really well in your past trainings that everybody can see at janesusa.com/trainings, but I would like you to comment on that today, if you would.
Yes, definitely. Yeah, please go back and watch the former trainings. But I'm really glad that somebody brought that up, because that's very crucial. Again, I'll go back to my comment, I'll go ahead and eat a little bit of crow, I guess. But, a sensor is just a sensor. It's going to report whatever it's reading. So if it's not installed properly, then you will still get quote unquote bad data in, and that will give you bad data out, right? So sorry, try not to be too long-winded here to quickly answer it. So typically, rule of thumb is here, when you install a soil moisture probe, if you've got a berm, you want to be about 3/4 of the way up the berm. So that way you're not sitting down in the pooling at the bottom, but you're not too dry being at the top. And you want to be within the nearest within a foot of the nearest drip emitter. Now, if you've got micros out there, when you think about the throw of the micro, 80% of that water is going to be on that outer portion of it. So this is where it gets really tricky if you're installing probes in a young orchard, because typically, they'll say that they have the hats on the micros out there, forcing that water down to be near the bottom, where the root ball is for that young tree, but then they'll move that jet or that spinner, that sprinkler out as the trees grow up. So you want to try to either be strategical with where you place that probe, so that way you don't have to move it twice, but you're usually probably going to have to move it as the trees grow up, if you're not going to be able to have 80% of that water hitting where the probe is at. So it's a great question, definitely something to take into consideration, so you're getting accurate representation of what's going on.
Yeah, that's a great points. I really appreciated that. And somebody had also asked now, do the sensors lose contact with the soil? And is that a problem? And how do you deal with that?
Yes, so they can, if they're installed improperly. There's two different ways of actually going out, and there's actually two ways of installing these probes. So that's why I like the Syntec probes, is because if you remember that image that I showed, there's actually a taper to the body of the probe. And so the manufacturer Syntec actually provides an auger that you drill into the soil, and that auger is actually tapered exactly to the width of that body, and it matches it perfectly. So you can really, as the name indicates, you can drill and drop the probe into the soil. So that's the first way. And that creates a really good contact with the soil surface to ensure that you're getting good readings. The other way of doing it is you can use the soil augers, like what we talked about and highlighted in the ground truthing video. And you also see a lot of PCAs have these devices too. You can take a hand auger and auger down, and as you're pulling that soil out of the ground, collect it in a bucket, put a little water in there, create a slurry, and then you put the probe down in the hole and pour the slurry in there. So that way you're basically creating a contiguous, homogeneous soil environment around that probe that's form fitted to the probe itself. Problem with that is it takes a few days for that slurry to dry out before you're getting accurate readings of what the soil is reading. So not necessarily a downside, but just something to be aware of.
Yeah. Oh, that's interesting, right? I guess that soil is just so moist from adding the water to it.
Right.
It's not
Right.
really reflecting what's around. Okay.
Exactly. So I'm sorry, really quick. So yes, there can be issues. Rocks, roots, gopher holes can sometimes create air pockets, but you'll start to see those issues as you're looking at your soil moisture probe data. You'll be reading consistent, dry, consistent. You know that you probably have an air pocket and it needs to be reinstalled.
Oh,
Sorry.
that's a good point, right? So every 4 inches, yeah, you can see that.
Right.
Very cool. Somebody else is asking, they're just rapid firing these questions.
I'm totally fine with that. I love questions.
This is
great.
Good. You're really helping. So
I hope so.
how about soil salinity? How does this impact a probe? Can we tell soil salinity from these probes?
So yes, they have upgraded versions of these probes where the probe itself, the physical probe, looks the exact same, but the internals of it have sensors to actually sense salinity in the soil. So if that's something where you're concerned about saline or sodic soils out in your region, that might be a good option for you. I will warn you that they are more expensive, but again, what's the cost benefit ratio here? If this is something that's been plaguing you and causing you loss in crop and loss in quality, then it might be worth the investment to be able to track that and use that and be able to try to manage that a little bit better.
Yeah, and I think too, Connor, and I appreciate you say it costs more, but the additional costs, we're talking hundreds of dollars, not thousands of dollars.
Right. I mean, if we're thinking about all the input costs that go into a farm, it's really realistically, yeah, it's a large sticker shock if you're going and buying something at Costco. But when you're thinking about purchasing equipment for your farm, it's actually really minuscule compared to all the other investments that you're making on the farm.
Yeah. Okay, great. And then you did a really good job of telling us where to put the probe in relation to the irrigation. but where in relation to my whole farm should I put these probes?
Oh, that is a great question, man. Thank you, everybody. These are really good questions. I love talking about this. So this is really good. So I'm going to go ahead and show you something on Jane Logic really quick here. Okay, so we're going to zoom in here and we're going to look at something. So if you notice here, there's some houses here and we have a small road near the edge of the field. This is something that's called edge effect. And what you don't want is you don't want to be irrigating and managing based on these trees that are being afflicted by what's called edge effect. And edge effect is what happens when you have the wind and the solar radiation and the heat from like pavement and exposed areas, and your vigor and your crop growth is going to be weaker around those edges. So I typically like to go in at least 5 rows and 5 trees deep, or 5 rows in and 10 trees deep, for example, as just a real quick rule of thumb there, to get away from that edge effect. So that's a great question. I haven't had somebody ask me that for a while, but that's a really good question.
Yeah, no, it's boy, this chart too, this illustration, it's actually an image, right? It's actually a satellite image. What you're showing there is a great example for that.
Yes, exactly. So this is really helpful that you can actually see this. I'll go ahead and throw this on the other side here, so that way you can see this. So so if we actually zoom in, so we have a little bit larger view here, you can get a little bit better view of where this edge effect here, especially towards the northern part of these fields here that he's managing. You can really see it around this edge here where it's surrounded by 2 streets that are paved blacktop here. You can really notice that compared to this field that's in the middle, surrounded by 2 orchards, you really don't have that much edge effect going on except where the pavement is.
That's so fascinating to see, right? I guess that pavement's just holding the heat.
It really does. I mean, you can feel it, right? You go outside on a summer night and you go stand near the cement or the pavement and the air's cool, but you can just feel that heat radiating off of those heavy surfaces like that. And the trees feel it too, which is, why a lot of people will plant 1 row basically as a sacrificial row to help keep some of that stress off of the rest of their orchard.
Right. So another question coming in, Connor. So we're really focusing on increasing crop yields with the lowest possible minimum investment.
Sure.
So would soil moisture sensors be good? Would ET data be better, the same, worse? And gosh, what about satellite? And
yeah,
from an economical perspective.
Right. Well, I mean, if you're wanting to be really thrifty, really economical, you can just get away with satellite data, right? That's the most economical, the most thrifty you can be. You get a lot of really good information about that, and I'll move on to that here in a little bit. But that's a great place to start. If you've never used anything before, but you want a little bit more insight, trying to help with some of that decision-making process, making sure that you're making the right decisions or confirming that the decisions that you're making are right. Satellite is definitely a great way to go. If I had my way though, probably the best economical way to go is to do the soil moisture probe. Start with the soil moisture probe, because the way that we work at Mana is everywhere you put a soil moisture probe, you can automatically have a field monitored by the satellite data that you're seeing right here. So it doesn't really matter how big that field is. You can do your whole ranch if you want to. There's issues with that. Again, much longer discussion. But, again, thinking about, hey, where am I going to be putting my dollars? What's going to make most sense? If you buy a soil moisture probe site, you're going to get the satellite data included. And in my opinion, that's the perfect 1-2 punch combo right there. You're understanding what's going on below the surface. How are my trees responding? How are they reacting? And then you also can look at how much water is being consumed with the satellite data here. This is the image that I'm throwing up right here. So you can see, I can throw my mouse over here and you can see, hey, latest readings, I consumed 1.3 inches of water in 90% of my field last week. Just like that. What did that take me? 5 seconds.
Yeah. Wow.
So in my mind, if it were my money and it were my ranch, soil moisture probe with a satellite is, in my opinion, that's a great place to start. It's not going to break the bank, but you're going to get a lot of great information that'll help you with your irrigation management. Great question.
And I guess if you wanted to, you could just start with satellite and then advance later, right? Because there's nothing that keeps you from doing that.
And this is what it would look like if you're just doing the satellite by itself. This is the information that you would be getting with a really nominal cost at the end of the day. I mean, this is dollars per acre. We're not talking double digits. We're talking single dollars per acre per year.
Yeah.
In my mind, it's a no-brainer. It really gives you a lot of great information.
Yeah. Talk about cheap insurance.
Yeah. Mm-hmm. Yep. Exactly. And it's, it's every single week. You don't have to pay for a number of flyovers. You don't have to plan when the flyovers are going to happen. You don't have to have a drone pilot, whatever. It's from the satellite. It's already passing over already. So you might as well benefit from it.
Yeah. Wow, Connor, this has been a really information-packed webinar. Thank you so much. Is there anything else you want to touch on before we call it a day?
Well, yeah, these questions have been great, and they've definitely taken up a lot of our time, which I'm not saying is a bad thing at all. I'm really happy that everybody's engaging and talking more. Maybe we'll have to do a part 2 of this where we talk a little bit more about divvying up the hours. That would just be kind of the last point that I would make here is, after we've looked at, what our water consumption is, we understand what our current status is. We now understand how and when to irrigate. So we understand that we need to wait a few days instead of stacking them so close together. Then we can start looking at information like how much water was consumed last week, what's the forecast going to be for this week in number of hours based off crop models. And now this is where we can start divvying up and creating that irrigation schedule, saying, okay, I'm going to wait a few more days. I'm going to put on 10 hours. Then I'm going to wait a few more days. I'll go ahead and put on 14 hours. And then that's when you can really start to hone in and refine your irrigation schedule. So I'll just kind of wrap up with that and leave some more time for, I don't mind waiting on if you're okay to answer a few more questions, or I'll put my information on the screen, up to you.
Yeah, no, I've got a question too. If you can go back to that last.
Sure, 100%.
Right. But yep. I'm watching my water penetrate the soil and I'm in between the goalposts. When do I know when to turn off that water? Do I turn it off as it approaches the goalpost? Do I wait till it touches the one side of the goalpost, or do I wait till it penetrates halfway? What's a good rule of thumb here?
That is a great question. And this is why it's important to have access to this information. Soil moisture is something that doesn't change very fast. This takes hours to get down here. So it's actually, that's why it's so important to have access to this information to say, okay, I'm going to run a few test irrigations, see where I'm at, to figure out exactly how does my soil work with all this. And then you now have access to this knowledge that you wouldn't have had before. Going back to the very beginning, we're coming full circle here. Going back to the very beginning, instead of just saying, oh, I'll draw on 24 hours. I know I'll get down to 48 inches. Yeah, you will. But did you need to put on 24? Could you have gotten away with 16 and still have gotten the same results as you did? Instead of having all that gas sloshed out of your tank, well, instead fill it up, let it click, and then stop. You're good. You can move on, save a few extra bucks and save that up for the next time. Right. So I think that's really good there. And you can actually also open this up here just really quick. You can also open this up, and if it's too hard to scroll through here, it's actually shown in a tabular form down here. And it's color coded, so you can see the red shows when we went a little bit too far, for example, right here. So you can see green is, hey, we're good, we're within our goalposts. Red is, hey, we've gone too far.
Yeah, look at that too. The duration in hours between 28 inches and 48 was just a little over 2 more hours. So this really accumulates.
Right. Exactly. And again, something that I hit on, and I don't know if I talked about enough, but what your soil moisture status is going to affect how quickly or how slowly that moisture will actually penetrate into your root zone. So again, it's you got to take into consideration all these factors, but you can do so and do it a lot more efficiently and a lot easier with access to a soil moisture probe.
Yeah. Wow, Connor, again, you've taken a really complex subject and really made this understandable. I know I'm coming away with a whole lot more knowledge and information. Really appreciate that. Want to thank everybody out there today, especially all the good questions we got. Really appreciate that. We know you've got a lot going on in your days right now, so we're happy you spent a little bit of time with us. Please remember, we've got all the Jane's, all the training sessions at the janesusa.com/trainings. And as always, they are free. We also offer them as podcasts as well, wherever you listen to your favorite podcasts. You'll find us there too. It's really cool, Connor, to think that people are going to be working and listening to your podcast and understanding better what they're doing as a result.
Mm-hmm. Yeah, definitely. No, I appreciate the opportunity to come on and share what I've learned over the few short years that I've been working in it. And I hope to continue to be able to do that in the future.
You bet. We'll look forward to having you back next month, I hope. And maybe we can go into part 2 of this, or review a little of this and get a little bit more depth into the other parts.
Definitely.
Okay. Well, listen, thanks everybody. Have a good rest of your day. And we're going to be back next week talking to John Petroso about Maisie fertilizer injectors and how you can use those to be more productive and improve your yield. So thank you.
Thank you, everybody.